Today we're taking a look at finding the midpoint of a line segment plotted in the coordinate plane. Now keep in mind the coordinate plane is the two-dimensional plane in which points have specific locations denoted by their coordinates. Therefore, a line segment would have specific endpoints denoted with coordinates as well. Now we're going to use those coordinates of the endpoints of a line segment in order to find its midpoint. All right, now let's just start off by trying this example. Here's a segment CB graphed in the coordinate plane. It has endpoints C, which is at -3, 2, where X is my -3 and Y is my 2. And then the other endpoint is B, which is at 1, -2. The X coordinate there is 1 and the Y coordinate there is -2. We want to start off by just exploring this. What happens if we take the average of the X coordinates? Well, remember, to average something, you add the numbers together and divide by the total numbers that you added together. So let's add our X's, -3 and 1. When I take a -3 and add it to 1, my result is -2. Now if I average that, I need to divide by the number of numbers I added together, which was 2. -2 divided by 2 results in -1. Okay, we're going to come back to that in just a second. Now what happens when we average our y coordinates? So we'll add our two y coordinates together, 2 plus a -2. That results in 0, but if we average that, we have to divide by 2, and 0 divided by anything is just 0. Now it says, does this look like the coordinate of the midpoint? Well, we have to take the -1, which was our average of our x's, and our 0, which was the average of the y's. And let's plot that point. Here it is, -1 over and 0 up. Does this look like it might be the midpoint? Well, as we just discovered in our first little exploration, the midpoint can be found using the coordinates of the endpoints. And all we're doing is we're averaging the x's, so we'll take our two x's, add them together, and divide that by 2. And we're going to take our two y's and add those together and divide that by 2. Now this x sub 1, y sub 1, don't worry about that subscript. It just represents the first coordinate and the second coordinate. It doesn't matter which order you add them in. Either order will work. Now remember, this is going to return the midpoint, which is also a coordinate. So when I average my x's, I'm going to get the x coordinate of my midpoint. When I average my y's, I'm going to get the y coordinate of my midpoint. Well, let's do an example. It says find the midpoint of a segment with endpoints R and T. So I'm going to start off by just labeling, here's my x and y for R, and here's my x and y for T. I'm going to average my x's, so that means I need to add them together and divide by 2. And I'm going to average my y's, which means I need to add those together and divide that by 2. When I do that, I'm going to end up with 5 divided by 2, which is 5/2 for my x coordinate, and 7 plus -1 is 6. 6 divided by 2 is 3. So here is the midpoint of the line segment RT. All right, let's take a look at example number 2. I see I have segment AB graphed here on my coordinate plane, and I want to find the midpoint. So x and y of coordinate A and x and y of coordinate B are going to be used in order to find that. I'm going to start off by averaging my x's. 0 plus 15 divided by 2, and then 8 plus 8 divided by 2 is the average of my y coordinates. So that gives me 15/2, which simplifies to 7.5, and that gives me 16 divided by 2, which simplifies to 8. Now if I go ahead and plot that point, 7.5 over, 8 up, you'll see in fact that is the midpoint, breaking that segment AB up into two smaller congruent parts. All right, in the next part of example 2, we now have a line segment that's has a little bit of a slope to it. We want to find its midpoint. So we're going to use the same tactic here. We're going to average our x's, which is now -5 plus 5 divided by 2. And we're going to average our y's, which is 3 plus 13, divide that by 2. Again, we're going to end up with 0 over 2. 0 divided by anything simplifies to 0. And we have 16 over 2, which simplifies to 8. So our coordinate here is 0 over and 8 up. And if we go ahead and plot that 0 over and 8 up, again, it looks like that should be our midpoint, breaking segment AB up into two smaller congruent segments. All right, moving on to our next examples. Now, the midpoint formula is not only helpful for finding the midpoint, but it also can be helpful for finding an endpoint when we're given one endpoint and the midpoint, but don't know the coordinates of the other endpoint. Let's just call these x and y for right now. In order to find the coordinates, we're still going to use the midpoint formula. Remember, it's the average of the x's. Now I have 7 plus x divided by 2 should have resulted in 10. Likewise, I'm going to average my y's, which were 12 and y, and when I add 12 plus y together and divide that by 2, I should have got 3, which is the y coordinate of my midpoint. All right, now let's just simplify, let's just solve these for x and y to come up with a coordinate for b. In order to solve this first one here for my x coordinate, I need to multiply both sides by 2. I need to undo this division by 2. So I'm going to multiply this side by 2. What I do to one side, I need to do to the other side. So I have 7 plus x is now equal to 20. Subtract 7 from both sides. X, my x coordinate there of that endpoint, should be 13. All right, let's do the same procedure for finding my y coordinate. I'm going to multiply both sides by 2 to get it out of the denominator there. I now have 12 plus y is equal to 6. Subtract 12 from both sides. My y coordinate here is negative 6. So the coordinate here for b should be at 13 over and negative 6. And if you look here on the coordinate plane, it looks like we're about 13 over and down 6. All right, there's one other way that we can go about finding the coordinate of the endpoint of a line segment when we know the midpoint. Now remember, the midpoint is just the average. It's the halfway point. So let's think about this in terms of movement. If I'm here at B and I'm moving to my midpoint, I need to move left. And when I move left on the number line, I'm moving a negative number. So if I'm going from 5 here to 1, I must have moved negative 4. Likewise, let's go from B down to C. If I move down, I'm moving from this positive 5, which was my y coordinate, to positive 4, so I must have moved down 1. Now remember, the midpoint C is the halfway point, so I have to move that same amount of movement across from C and down to get to A. So I must have moved another negative 4 and another negative 1. So if I'm at C and I move negative 4, then that's going to place me here at negative 3. And if I'm up 4 and I move down 1, it must place me at positive 3. So the coordinate here for A must be negative 3, 3.